Next up, we have Thomas Batin, who's CEO from Linkster, and Laura de Wilde, who is a fashion designer at Incanu. They're going to be exploring how 3D printing is transforming fashion and design, looking at sustainable production, personalization, and the use of innovative materials like silicone for creating unique, eco-friendly garments and accessories. So, over to you.
Thank you a lot. Thank you very much for attending this presentation. It's an honor to have this opportunity. We'll talk about additive manufacturing and fashion and fabric. Let us introduce ourselves first. My name is Thomas Batin. I'm the CEO and co-founder of Linkster. I'm an industrial engineer, and my job is to make machine that works, figure out materials and ways of making things. And today at Linkster, we are one of the leading companies in the elastomeric world for additive manufacturing, mainly focusing on silicones and polyurethanes. We are a French company. We're about 30 people. It's been a couple of years now that we're coming at Formnext, and we face a pretty extensive growth internationally at the moment.
Hi, I'm Laura de Wilde. I'm a French fashion designer. I created my own brand in 2020. It's called Incanu. It's a handbag brand based on the neo-artisanal process. It means that it's combining 3D printing and craftsmanship. The goal is to offer a new handbag with a new shape and design. And I also teach in fashion school the creative process of 3D printing. I met Linkster and Thomas 2 years ago, and when I met Thomas, I feel immediately the same passion for 3D printing and also for creating in fashion, in accessories. And after a few discussions, we decided to explore the possibility of 3D printing in creation to print of combining different materials, different techniques, and in the way of creation and fashion. So the first phase was to discover their technology, and for me it was very exciting because before that I only work on the FDM technology, and so I discovered the silicone printing on fabric.
And we kind of share the same vision on it's not necessarily smart to print an entire handbag with just a single material and the limitation that goes with it, but maybe combine traditional craftsmanship with new technologies such as silicone 3D printing. And we started working with these new devices. At the time, it was really the very beginning of this new machine. And this is a silicone extrusion machine. Basically, it prints material in a liquid form factor. It's very, very viscous. And by using on a side a silicone printing tool head and a water-soluble support printing tool head, we can combine the both to make pretty complex geometries. That was the very, very beginning of these machines. And one of the key aspects of material extrusion is the fact that you can print on something. You're not limited by a vat of powder, of liquid. You can print on something directly. And it kind of clicked, and Laura visited us at Linkster early in the process, and we're like, okay, let's just try do something. Let's just try print some shapes and figure out if it adheres, if we have the expected properties, and let's get something printed. So that was very first trials, trying to see if we could lay down the material properly. And then we quickly realized that we will have to go pretty far by reformulating some materials, figuring out the right colors, mixing that homogeneously with the right machinery to not incorporate any kind of bubbles and have an homogeneous mix. We also realized pretty quickly that because we are extruding material on a fabric, it can tend to flow or not flow. It can be a bit jelly, it can be very flowy. So we had to qualify all of that, the rheology of the material, in order to forecast the behavior of the material as much as we can when it will be printed on fabric. We printed a lot of test parts to characterize the mechanical properties of all of these materials and characterize also the adhesion factor. That's something that's pretty difficult to figure out, like how much it adheres, and shall it adhere? And shall it adhere to cotton? Should it adhere to leather? And that's something that's pretty tricky to do today on the market. If you're looking for 3D printing on leather, for example, there ain't that many solutions, because that's a pretty tricky thing to do. So a lot of science and R&D to figure out how we could do that. And then we were also facing a lot of limitation regarding the way we lay down the material, the way we slice, the way we generate the code. So we started working with conventional slicing. I mean, you could call it this way. It's basically take a shape, slice it in planar layers, and then you try to populate that. So basically, you try to draw the perimeter, and then add the color in the middle without going away from the perimeter. It's pretty cool to start, but then you don't really enjoy you can't really exploit the capacity of making a texture out of it. It's pretty much an imprint. And we can go definitely further. So we started developing a lot of different modules, slicing custom modules on Grasshopper and other utility, in order to really make the nozzle dense on the fabric, over extrude, under extrude, squash the material, put it back, and get nice results. So the first thing we came up with was this one. It's like a combination of a lot of different triangles that really catches the light. That is super, super soft, and you can extend it quite a lot. And I mean, again, I'm just the engineer. I found that cool, but Laura kind of, it rang the bell in Laura's head, and she was inspired, and she started to do something with it.
And we decided to adapt this pattern on an existing model. It's called Prism. It's this one. Maybe you can take, there is a bag here.
There are plenty of bags here. You can just like take them and maybe pass them over.
And the inspiration behind this bag, it's a brutalist movement. It's with angular and geometric shape and the play on the solid and the void. And we decided to put the pattern on this bag. And after creating like this weaving pattern, I have this new and exclusive product. And for me, it helped me to showcase the brand with a unique pattern printed directly on the laser.
So the whole point was to be sure that the silicone adheres on leather. So in this case, because that was also pretty early in the process, we went straight towards RTV1 silicones. For the one who know, RTV1 silicones are kind of a sealant. They're meant to be a glue, and so they tend to adhere pretty well. They cure with the moisture that's in the air. You just leave it there, wait a bit, and eventually that cures, and from liquid, it becomes elastic, and that adheres to the leather. It's pretty straightforward, but it's not very handy to print with that, because whenever you see moisture, it tends to cure. So you can clog nozzles, and that's not really what you want to have. And we were facing also a lot of limitation when it comes to the color. If you include pigments in this material and you mix them, you tend to incorporate moisture as well. And so you end up having the silicone that starts to cure inside the pump. And that's not really what we wanted, and we wanted to go way further in terms of color. Then Laura was very much into this pattern, but we wanted to push it further. And we wanted to mimic some other pattern that we had in mind and try to mimic really this waving fabric effect when it goes under and above and under and above, which is very difficult to do with a 3D printer where you just print from the top and you need to figure out a way to go under. So with a lot of simulation, we figured out a way to mimic that and to really expand this texture and not having this kind of, again, imprint feeling on this one. And then Laura got creative with it.
And for this bag, so we started from scratch with no existing bag, and we want to have more volume. So I designed this bag. The inspiration, it's like a rocket with this shape, a rocket from the space. So I created this bag with this new pattern. So as Thomas said, it's like a wicker pattern, but a strange wicker pattern. And we have so a new product with a new pattern, a richer pattern. And with this shape, and inside the bag, we have a structure in 3D also to keep the shape of this bag.
So we challenged ourselves really on the design and on the texture, but we were still stuck with these RTV1 silicones that we could not color. So we found black one, we found white one, we found silver one, but that was pretty limiting still. And so that took us some time, but this one took us actually, if it wants to go to the next one. Oh. All right. We've been challenged by a big entity on making flowers. That was very trendy at the time, and we wanted to come up with something very floral and something that kind of flies over the pattern itself. So we innovated a lot in this case because instead of using RTV1 silicones, we used LSR 2-part silicones. It's actually a medical-grade implantable silicone that we've used to make this bag. And then we played with support structure that are water-soluble in order to print the flowers on top of it and dissolve this water gel afterwards. And the result is something that's very, I don't know how to qualify it, but that's very seldom. That's very unique. And the pros with that is that it's very strong. The issue is, though, is that it does not adhere on fabric anymore. So we end up with a very strong fabric itself, but we need to connect it with the bag. So the bag has been designed this way in order to include this new kind of fabric in it.
So this is the last creation of my brand. It's called Comet. The inspiration, it's like for the shape, it's like a spaceship, sorry, and with a flower come from space. The idea was to be more free and creative in shape, but also in color. So that's why we use this new silicone. And for design it, I have to think. I have to think how to do this bag because it's not print on the laser, but it's like a 3D textile with this flower.
And something we did not mention, but the fact that we could actually play with the color meant that we were also capable of incorporating bio-based or vegetal or natural pigments inside. And for this one, we decided to work with a grape anthocyanin, which is the molecule that colors the grape, and we can actually extract that and reuse it in the silicone to color the bag. So really a lot of freedom, and also working on the code itself, we could really print only the parts we wanted and not generate any waste, having to cut the pattern afterwards. This bag has been featured in Emily in Paris, the Netflix show, because I think it was so unique and new, and with biosourced ingredients and a lot of innovations. So it's the second time now that one of our bags make it to Emily in Paris, and that definitely kind of put a big spotlight on Inconnu brand. Now we see a lot of application possible with this technology. The first one is with clothes, and you've been inspired by that as well.
Yes, maybe for this sample, it's like a new lace in 3D printing, and I think it's very interesting because it's prints on organza, but we can imagine also prints without fabrics, like a new 3D textile, and we can, with this tool, we can imagine to create your own lace on your own design, and it's like very flexible, and also like the feel of it's soft touch. So, and we can be very creative with many color and many fabrics and many design.
Another one is the shoe. At the moment, there is a bit of a hype around 3D printed shoes. And again, this is a topic of interest for us because today what we see is very often monolithic shoes made out of the same material. Which is interesting, but there are a lot of limitations and a lot of things that are actually tackled by traditional craftsmanship of making shoes that are disregarded by doing monolithic shoes. So we believe by using this technology, we can actually combine things and put additive manufacturing where it should be in the shoe design. Using leather or recycled leather in this case. We're talking about recycled leather out of luxury saddles for the horse riding, from the horse riding industry, which is working pretty well. By the way, everything that we show right here can be shown in our printing on textile booklet. That's available on our booth, the E2 on this hall at the end of the alley. Another one is cinema.
Yes.
There are currently movies being recorded with costumes made, cosplays were made with these technologies. So we are looking forward to the release of this movie, so you can see what we've been doing in this area. That's really inspiring for these designers.
Yes.
And finally, another one is the healthcare industry. A lot of time you find silicone printed on fabric for non-slipping properties or for compression properties, and it's pretty easy to clean as well. So for people who've been burnt, for example, in order to press on the wound, this is the kind of thing that can be used. So now we see very interesting crossovers from the fashion design industry towards healthcare to help burn children, and that's something that we are very proud of, and that we really invest on to spread the technology as much as we can. All right, thank you for your attention. You can find our contact details on our mutual websites and Instagram, and if you want to continue the discussion, we can meet up at the booth for the one who are interested in this kind of technology. Thank you for your attention.
Thank you.
Thank you very much. Does anybody have any questions before I jump in? I just wanted to ask, so obviously on the lace material, that's quite a fine detail. So what is the limit of the process in terms of small details and fine details like that?
It's still a material extrusion process, so we are limited by the size of the nozzle and the kind of viscosity or particles that are in the material, right? So if it's a highly filled material, we will tend to use a bigger nozzle. What's interesting, though, is that by playing with the way the nozzle moves in the space, is that we don't necessarily have to make very thin details. We can just push back the material to make this waving effect. So we end up with very accurate things, but that are not directly coded or not directly designed in the CAD software. So that's a bit of a trick. And you also have to keep in mind the productivity of it, because if it takes, 20 hours to print the flowers, it just doesn't make any sense. It's got to go fast, and we need to bring details thanks to the process itself.
And the water-soluble supports that you used on the flowers, is that an internal development that you've created, or is it something that other people can use?
It's a very simple proprietary material that we've developed at Linkster in France. It's a proprietary formulation, and we produce this material on site. So we make sure that nothing's toxic, formulation is super easy, and that it's non-toxic when it's dissolved in water and goes to the sink. Yeah.
Perfect. Thank you both very much. Yeah, please do take a chance to go down and see Linkster's booth, and you can see some of the samples. Make sure you get the bags back.